Denoise is a tool that can reduce everything from excessive noise to dirt from your image sequence. Denoise does this by combining motion estimation techniques with edge-preserving filtering methods. In this tutorial, we will look at different examples and how to approach the easy-to-use controls so you can apply what you learn in this tutorial to similar scenarios. Let's take a look at this first example. This is a noisy video sequence. It's 640 by 480 at 29.97 frames per second. You can see that the image is squished, and that's because it's anamorphic. You would want to remove the noise prior to scaling the image horizontally, otherwise the noise would also grow horizontally. We can add denoise, and you can see right away with just the default settings that we have a much better result. We can take a look here at the effect controls. We have two types of processing. We have spatial noise reduction and temporal. We can start by turning both spatial and temporal to none so you can see what they do. Sometimes you will want to use one or the other, and sometimes both. Simply put, spatial processing adds a bit of blur. If we use spatial, you see we have several options. Diffuse will average values within the area defined by the spatial radius. Pixels are averaged with the center pixel of the blur only if they vary from the center pixel by less than the spatial threshold percentage. This spatial threshold defines how much a pixel can differ from its neighboring pixels. A value of 0 essentially turns off spatial filtering, and a value toward 100% will include pixels in a greater range of pixel values. This effectively allows you to limit blurring from creeping over big changes in the image, like at edges between objects in the image. This is a much more intelligent way to blur in order to reduce noise without blurring over important features. I'm going to change the spatial radius to 6 for this example, and when I change the spatial threshold, you can see the different results. We can leave it on 20 for this shot and go back to 3 for the radius. The smarter blur option will use a Gaussian blur instead of averaging, also utilizing the threshold percentage. Blur bias towards darks does just what it says and is good for dark footage, and blur bias towards whites also does what it says and is good for footage with large and noisy white areas. For this example, we're going to leave it on Smarter Blur. We will leave it on 3 for this example. Now let's look at the temporal process modes. The temporal process attempts to reduce noise by tracking each pixel through several frames and averaging them. To track the pixels, the plugin uses optical flow between the current frame and the adjacent frames. If you choose Average, it warps the previous frame to the current and the next frame to the current frame and mixes all 3 equally. Median uses the same 3 frames but keeps the median of the 3 values. Average to most similar pixels uses the same 3 frames, but it discards the most different pixel and averages the remaining frame to the current frame. This is a good choice for dropouts or non-recurrent dust or dirt. Average with previous warps the previous frame and the current frame and blends them equally. Average with next warps the next frame to the current frame and blends the two equally. One reason to provide the 2 directions, previous and next, is for shots when you zoom in or out. Ideally, you would like the other frame to be the wider field of view. For a zoom in, you would use previous, and for a zoom out, you would use next. With min, it warps the previous frame and the next frame to the current frame, and it keeps the minimum of the 3. This would be a good choice for a shot with too much rain specularity or shots with sporadic flash frames. Max will warp the previous frame and the next frame to the current frame and keep the maximum value of the 3. This would be good for black dots. We will leave this on Average for this shot. The temporal quality is pretty self-explanatory, but I will run through it. No MV turns off motion estimation completely. Best forward warp is a high-quality motion estimation and high-quality warp filtering. It is slower but more precise. Best inverse warp is the high-quality motion estimation but with faster warping technique. Medium is a faster motion estimation, and fast is using a much lower resolution motion registration. We will use medium for this shot. The temporal threshold percentage controls how much a pixel is allowed to vary after it's processed. A value of 0 effectively will turn off the temporal denoising, and a value of 100% is the absolute maximum deviation from the source any particular pixel is allowed to change. If you see ghosting of multiple edges of an object in the images after processing, turn down the temporal threshold. This happens when the internal tracking does not work perfectly. In this case, we will leave it at 20. You will notice that if you get ghosting on your image, that the threshold is either too low or too high. We will discuss the rest of the controls as they are used in this tutorial or in part 2 of the denoise tutorials, or you can refer to the user manual. Let's take a look at the before and after of this shot. Let's look at our second example now. This is an outdoor shot taken at night. You can see the coarse grain mostly in the clouds of smoke. Since it's primarily a dark shot, we're going to use the spatial noise reduction with a blur bias towards darks. We will go with a larger radius than we used for the last shot because the grain is coarser. We will use 5. For the spatial threshold, we will use 20. We will also use the temporal process average to mix the previous, current, and next frame equally. We choose the temporal quality on best forward warp and the temporal threshold on 100, so we're allowing those pixels to deviate from the original to the maximum amount. We can see on the before and after of this shot that we have a much better result. In this next example, we can see that we have some noisy film grain. I will show you 2 results. One will be a little more and one a little less denoise because we have complete control over the resulting look. We can start with the heavier one first. We will use spatial noise reduction with blur bias towards darks because it's a dark shot, and the spatial radius is large because the grain is also coarse. We have it at 5.90. We have the spatial threshold at 100 to allow the maximum amount of change to occur to the pixels. We are also using temporal process at average and the quality at best forward warp as well as the temporal threshold also at 100. This result may be a little overkill, so let's see another option. We can take the radius down a bit to 3 and the spatial threshold to 20 and see that it still removes the noise, but the result is a little less blurry. Now I'll play the original followed by the first result and then the second. The point is that ultimately you have control over the look. I would like to show one more example for this tutorial. This shot is not only noisy, it also has a lot of specks of dust and dirt. In this case, we can run 2 passes. We can start with a temporal process, which averages the 2 most similar pixels out of 3 frames. So if you have an imperfection, like the hair on frame 16, and doesn't appear on the frame before or the frame after, then it will disappear. We run this pass prior to the overall noise reduction pass because if we did it the other way around, we would make it difficult for denoise to find the specks of dirt and dust separate from the noise. One last point I'd like to make in this tutorial is that after all these feature-preserving noise reduction methods are used, the final image may be too soft for your taste. Denoise also integrates contrast and sharpening enhancement for a more complete, one-stop final look control. We will cover these settings as well as a few more and some other examples in the next denoise tutorial.